Hello, class. This would be, I believe, the last of the recorded lectures for section 4.4. Again, solving basic trig equations for their angles and giving you the complete set of all angles that would cause this equation to be true. And so we introduced this idea of factorization of some trig equations. And I'd like to go through a couple more of those right now. And so the first one that I like to go over, and this one I find a little bit tricky, is 2 cosine squared of theta minus 7 cosine of theta plus 3 equals 0. And you look at this equation and it's like, oh, well, what I like to do is convert it into an algebraic looking equation. So I, in my head, can think about it so it's easier to factor. So this would be 2x squared minus 7x plus 3 equals 0. And I know a lot of time and effort has been devoted to factoring in math. And factoring is kind of an art form. And when the a value is not 1, it is a lot more complicated. And so the idea here now, which is nice, is the a value and the c values are both prime numbers. So there's not a lot of factors to think about, right? So when we think about factoring this, we would want to factor it where we want the b value has to be minus 7, right? And remember, both the a and the c values are both positive. So we need to have 2 minuses involved with this, right? So I will just put the minuses right here. And one of them is going to be a 3 and one of them is going to be a 1. So minus 3 times minus 1 gives us plus 3. And now where does the 2x go and where does the x go? And so the idea is we need 7. So we need what? 6 plus 1, right? So this 2 has to get multiplied by that 3. So the 2x would go here and the x would go here. There's other ways to think about it. And again, there's not an algebra class, but I'm not going to go through all those. This is how my mind works when I do factoring. But you do have to realize you can use the quadratic formula to solve this. And so I do want to show you that one time. And so remember, I personally like to write the a and the b and the c values out. And the quadratic formula is minus b squared, or excuse me, is try again, negative b, and then plus or minus the square root of b squared minus 4ac all over 2a. So you could solve for these values, and these are going to be the factorization forms that we have up there. And I'll show you that when we get there. So let's plug in the numbers, see what we get. So b is minus 7, so it'd be minus a minus 7, right? And that would be plus or minus 7 squared minus 4 times 2 times 3, all over 2 times 2. So let's do what's inside the square root. It's called the radical, right? And so that would be 49 minus 24. Say 12 times 2 is 24, so that would be 25. So you would simplify this a little. That would be plus, and this would be plus or minus the square root of 25 over 4. So when we do that, we get 7 plus or minus the square root. We don't need the square root anymore, right? What is the square root of 25? That is 5 all over 4. So we'll have 2 solutions, right? 7 plus 5 over 4, and that would be 3. And then 7 minus 5 over 4, right? And that would be 1/2. So these are the two zeros of that quadratic equation. And that these two would be the ones that you solve for in this case, right? So what is x? If I plug 3 in here, 3 minus 3 equals 0. Solution 1. Solution 2, I plug in 1/2 here. 1/2 minus 1 equals 0. Solution 2. So there's that way to solve it, right? And so I'm going to get the eraser out, give myself a little bit of space here. So there are two ways to solve it, and I showed you both. The third way is completing the square. To me, that's the most challenging of these, but we're going to do that in another section, so I'll wait for that. And so how would you do this? Well, you would have 2 cosine of theta minus 1 equals 0, solving for this one here. All right, you'd have cosine, 2 cosine of theta equals 1, cosine of theta equals 1/2. Boom, there's our answer right there. So if you use the quadratic equation, you already have, these are the values that the cosine of theta, which we defined as x, right, will have to equal. And you see when we do the other one, it would be substituting in cosine of theta for x, you get 0. And you see here we have cosine of theta equals 3. So don't be scared of the quadratic formula. In real world applications, nothing is factorable. And so you see that if you need to solve a real world equation like this, and you're not going to be able to factor it. So getting familiar with the quadratic formula is quite helpful. I think the good news is, what is the answer for cosine of theta equals 3? Again, that's no solution because cosine maximum value can be +1. But we do have cosine of theta equals 1/2. And remember, cosine is positive and what is it? Quadrant 1 and quadrant 4, right? And so this idea of quadrant 1, if I looked at my little table, cosine of 1/2 is 60 degrees, or pi over 3. And so quadrant 4 would be down here at -6. This would be 60 degrees here. So if we go all the way around, that would be 300 degrees. And 300 degrees would be 5 pi over 3. So the solution set would be twofold. Wish my whiteboard was a little bit bigger here, but we're doing all right. So in this case, the one solution would be pi over 3 plus 2 pi n. And the second solution would be 5 pi over 3 plus 2 pi n. And if you take a look at the book, I took this one right out of the book. Let me show you what the unit circle graph would look like. They have a nice pretty picture here. And so again, this is the vertical line of x equals 0.5, and it intersects at 60 degrees and 300 degrees. And then every time you go around clockwise, the n values would be +1, +2, excuse me, rewind. When you go counterclockwise, that's positive, and so n would be +1, +2, +3. And n goes negative, that would be clockwise. So you would go around clockwise for n equals -1, -2, -3, etc. Okay, one more example. Again, this time we're going to throw in a little more complication maybe, or maybe a little less. This one has both a sine and a cosine in it. And we're going to do a lot more of these in the last section. So this would be sine of theta, 5 sine of theta, cosine of theta, plus 4 cosine of theta equals 0. Okay, well, what do we do with this? Well, there's a couple of things. I see the factorization right away because we have a common factor of cosine of theta here. So remember, when you see a common factor in both of the terms, and the terms are separated by a plus or a minus, we can just factor that out. So if you do that, you would have cosine of theta, and then we could have 5 sine of theta, and that's what's left in the first term. What's left in the second term is just the 4, so that would be plus 4 equals 0. So when you solve this, the first solution would be cosine of theta equals 0. And so how do we solve for that? Well, cosine of theta equals 0, I believe occurs, this is 1, right? So the x value, so that would be at 90 degrees or at 270 degrees. So when you do that one, it would be pi over 2 or 3 pi over 2. So when you take a look at this solution set, it would be pi over 2 plus or minus 2 pi n. And then, not plus or minus, plus 2 pi n, sorry about that, or 3 pi over 2 plus 2 pi n. And when you look at that one, you see that these two values are separated by 180 degrees. So if you think about it, you could rewrite it as pi over 2 plus pi n to simplify it. And I know that's a little bit tricky, but let's think about this a little bit, right? So if you look at this calculation, right, we're at 90 degrees, and I'm going to talk in degrees. So how much do I have to go around to get here? 180, right? Or pi. And then if I go another pi, I get back to where I started again. So mathematicians like to write things very simply. And so this combination, which engineers would be happy, can be rewritten as a simpler form, pi over 2 plus pi n. And that usually only happens with regards to when you simplify this, if they occur right at nice numbers that are exactly 180 degrees apart like that with regards to it. So let's go back to the sine one and see what we get. And so in this case, we go back to the sine. Let me do that in red. We have 5 sine of theta plus 4 equals 0. So we solve for that. You'd have 5 sine equals minus 4. So sine of theta equals minus 4 over 5. And if you did it in decimal, it'd be minus 0.8. So I look on my little sheet, and I don't see, 4 over 5 on my table, right? So how do we solve this equation? This equation here would be, I have to get my calculator out. Hold on one sec. Okay, find my calculator. So I turned the recording back on. So if we do the sine inverse, right, this would be theta equals sine inverse minus 0.8. And if you get out your calculator, you would get minus 0.93, rounded to 2 decimal points. And so remember, sine inverse is good in the 4th quadrant, right? So that would be the 4th quadrant. But what would be the value for negative also is in the 3rd quadrant. So you can see a little bit of complication here, right? So here would be minus 0.93 radians. coming down here. And then to get to this point here, how would you indicate that? Well, if you think about what we're moving with regard to that, this would be, I need some more space. Okay, so let me get a little more space here. And so when we take a look at this, it would look like this. So the first one is we're moving minus 0.93 radians clockwise, right? And so that is the point in quadrant 3 or 4 that gives us a negative sign. So now we need to get to quadrant 3 to get the other negative sign, right? So if you think about it, we're going to move what? We're going to move over here. We're going to have right triangle that looks like that. So our right triangle would be right here, right? And so this angle, again, would be 0.93 radians. So what would be that angle in radians? Well, typically, we're going to leave this one as a negative, but let's calculate this one as the positive angle. So we need to move 180 degrees, right? And then we need to move another 0.93 radians. And when we do this calculation in WebAssign, you're always going to put it into radians. So what is that in pi? Well, let's just do 2 decimal points. So pi is 3.14, and then you add that together, another 0.93. You would see that would be approximately 4.07. So the solution set for these two would be minus 0.93 plus 2 pi n. And then the other one would be 4.07 plus 2 pi n. And so what would that look like? Let me show you the little unit circle here. In the book, they do a nice little better job than my drawing, but my drawing not too bad, right? So here's the unit circle, and here's the first one, minus 0.93 radians from the going clockwise, right? Because we're minus. And now we need to get to the third quadrant, which is the other negative value for sine. And so here, this value here would be 0.93 radians with our right triangle going up to the negative x-axis. So you go all the way around, that's a pi, so that'd be 3.14. And then you add 0.93 and you see you get approximately 4.07. Remember, pi with 2 decimal points is 3.14. And so the other solution here is, here's the cosine, and they didn't combine this one as I combined it. I believe in section 4.4, you don't combine it. And then in section 4.5, we bring that complication together. And here are the 2 solutions for the sine. And here they're using k for any integer. And in the values that I used up here in the whiteboard, I used n for any integer. Typically, and most things that you do in the math world, the value for n and k are interchangeable, where n is typically given as any integer and k is also given as any integer. So make sure that when you look at the WebAssign, sometimes they're going to tell you use k and just use k instead of the n values that we see here. So I think this was the most challenging of the problems here with the trickiness of having both dealing with sine and cosine, factorization, etc. So that ends the recorded lectures for section 4.4.